Welcome back, everyone. Today, we're going to talk more about the materials that are around us and what properties they have. Now, as a reminder, properties is a describing word, like an adjective. It tells you about something. So when we say, what property does a water bottle have? I could say, it's hard, and then we can test that and see, yep, it's hard because if I drop it, I want to make sure that it's okay and that it's not going to break and water goes everywhere. So it's really important to understand what properties all materials have. And we're going to talk more about that today with some science activities. Something else I need your help to identify is, what is this? This is actually a pie tin. And I love pie tins because of what usually goes inside of them, but I also use them for science experiments sometimes. Now, the reason I use them for science experiments is they're made out of metal, so they're pretty hard. It's not just musical, but they are very hard. So that is a property of this material. This is an aluminum pie pan, and its property is it is hard. So when I'm doing things like baking pies, we can bake them in this because it's hard, it's strong, it's a little flexible, okay? And flexible means it can bend, okay? Just like our hand, we're flexible. We can flex our fingers, our muscles, and sometimes materials like some metals, like aluminum. It's a very thin aluminum. And so it's hard, it's strong, just a little bit flexible, and that helps because when I put a pie in here with that weight, I want to make sure it doesn't accidentally spill. I want to make sure it's actually going to be a pie that I can put inside of my stomach. Another material I'm bringing you today is actually a science jar that we use in science to store things. Now, this can be a little different than other jars. This jar is made out of plastic, so I identify it's made out of plastic, and I can kind of help because on the bottom there's a little triangle, if we can see, that tells me that it's recyclable too. So it's plastic, that means it's a little flexible but pretty hard. If I push, you can see it go in. If I push too hard, it actually stops me. And there's another property that it has. It is transparent. If I hold it up, you can actually see Freddy Bones through the jar. So that means you can see through it. Light can travel through one side and out the other. And so transparent is good because then I can see what's inside the jar without necessarily having to smell it, put my head over it, or touch something on the inside. So transparency is a property that helps us. As a scientist, it's important to test out those materials that we have around us sometimes. So, since it's getting close to the time where people might be getting sick when it starts to get colder out and the weather is changing, sometimes you have to blow your nose. Now, I didn't really use this tissue so it doesn't look gross and it's not gross, and I'm not really sick, but I want to make sure I use the best material because I don't want to blow my nose into something where it's going to get me all gross from the snot that was inside of my nose. So one way you can do that is with a spray bottle. Now the water inside the spray bottle is going to kind of act like the snot in your nose. We want to make sure that the tissue absorbs or soaks in whatever we're going to put on it and holds onto it a little bit. So that way we know if we sneeze on it, it's actually going to keep all the gross stuff from inside our nose on the tissue. So I'm going to practice spraying it. This is our test to see if it can absorb water. Whew, that was a lot of sneezing that I put on there. But I can look and see that it's changed a little bit. You can see the light kind of going through it. The wetter parts are a little bit more see-through than the darker parts up here. And it's still kind of tough and absorbed all of those sprays of water. So that is a test you can do to test and see what materials are absorbent. And that's a property of this tissue, is it is absorbent. Here we are in our science office and it's time to do a science experiment. So the experiment that we're going to do today has to deal with dropping things. So I have three objects that I brought for us to talk about today. The first one is a little beach ball. And this beach ball is pretty light. It's empty on the inside. If you've ever been to a beach or you have a soft toy like this at home, you know that I can hit it. It bounce high, pretty easy. So let's talk about some of its properties. Okay, it's pretty light. It's soft. Okay, soft. Okay, not as flexible. It doesn't change its shape very easy. And it's very colorful. Color doesn't really help us with how it works sometimes. It may look really nice, but color always isn't super important. So that property doesn't matter as much for our science experiment today. Okay, so filled with air, so empty on the inside, lots of colors, soft. Then we have a balloon. So I have a balloon. It is red. Remember, color doesn't matter as much. It's also empty on the other side, and you can't see it, but this balloon weighs a lot less than that other one. So it must be made out of a different material, which it is. It's made out of a rubber, whereas our beach ball was made out of a plastic. And then finally, I have a golf ball. Now, golf ball is a little bit harder to see, so I'll bring it closer, have some texture. So they're bumpy on the outside. They're very, very hard. If you know what golfing is, you know that you use a club to hit it really hard. So it has to be hard so that way it doesn't break. So if I hit it with my hand, nothing. It's not soft like the other things. It's very, very solid, and it's actually a little bit heavier than our beach ball and our balloon. So, smaller but heavier. That must mean that on the inside, it's not filled with air. That might be an experiment we perform on a different day where we cut into a golf ball, but not today. So, here's ways we can test it out. I want to see or know which ball will bounce the highest. Now, if I want to test that out, I want to make sure, number one, it's okay to drop the objects I have, which I already have, and make sure it's on a surface that's okay too, and that you're safe, there's nothing around me that's going to break, and I got permission. So, let me start by dropping the beach ball. Let me lower our camera so you can see the results. So if I drop our beach ball, okay, you can kind of see it bounce a little bit. Let me drop our balloon. Now let me drop the golf ball. And stop the golf ball. Now, in our experiment, we saw that they all bounced a little bit differently. Which one was the best? Which was the second best? Which was the third best? So, if you're with me, the golf ball bounced the highest, and a lot too. So it just kept bouncing and bouncing and bouncing, 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 bouncing. And then the beach ball was the second best. So it bounced, it did a couple more bounces, and then just kind of stopped. And it didn't go as high. And then our balloon, when we dropped the balloon, it dropped nice and slow, hit the ground, and then just kind of went and stopped. So if I want something that bounces the best, I would say I would choose the golf ball based off of our test. And I might use my scientific prediction to help me explain why I think that it bounced up so high. So I think the golf ball bounced the highest because, and then you explain your answer. So use that I think because, and then you go ahead and try to find some materials around where you live and figure out what they're made out of, why you think they're made out of those things, and good luck.